Among many celestial objects, there is one that holds the title of the Holy Grail of astrophotography. It is an elusive object. Capturing it requires the darkest skies and ideal atmospheric conditions, as well as long dark nights. People travel hundreds of kilometers to challenge their skills in equipment handling and image processing. Today we will dive into the heart of this structure to see what the sky looks like there. So buckle up and let's head towards NGC 5907. In the silence and chill under the dome of stars, the boundary between man and the cosmos disappears. In the darkness, senses sharpen, and the sky becomes so dense with stars that constellations are hard to find. Everyone has their own mission, from observing distant galaxies to photographing vast nebulae. Such gatherings give an opportunity to tackle the most challenging objects on the edge of detection with amateur telescopes. Our mysterious object is located in the constellation of Draco. It's easy to find. It is closely associated with the galaxy NGC 5907, which is tilted towards us. Known as Splinter or the Knife-Edge Galaxy, it presents itself as such in a telescope. A 10-minute photograph shows only the galaxy itself, and to uncover its secrets, another dozen hours of exposure under perfectly dark skies are needed. We've got it. A stellar loop as wide as our Milky Way, nearly transparent. It was discovered in 2006 by David Martinez de Lago's team, a relic of an ancient collision. To this day it is unclear exactly what the loop is a remnant of, but we'll get back to that. Let's first see what the sky would look like if we flew to one of the planets in this part of the loop. Out of the darkness emerge very old stars, billions of years old, predominantly red giants, K and M main sequence stars. They have low metallicity, meaning few elements heavier than helium. Finally, the entire sky is illuminated by the NGC 5907 galaxy, and we see it in full glory spanning the entire sky. The second part of the loop appears, hundreds of thousands of stars, largely similar to our Sun. The entire spectacle ends with deep blackness, a sight completely alien to the human eye, as from Earth we always see some stars. Let's fly to another planet at the very end or beginning of our loop. What would the view be like there? This galaxy has been known for over a century and was considered a model of a quiet, thin disk spiral galaxy until the publication of this discovery. Labs and observatories worldwide began analyzing their data. A new era of deep sky observation began, so-called deep imaging, led by scientific and amateur astrophotographers collaborating with professional institutions. In the following years, thanks to increasingly deep observations and simulations, something even more spectacular was discovered. To explain the observed structure of the loop, a collision of two galaxies of similar size was needed, about 8–9 billion years ago, not just a smaller one as previously thought. One of the most fascinating discoveries in NGC 5907 is the presence of an X-ray source named X1. It turned out not to be a medium-sized black hole, but an accreting pulsar. In other words, a neutron star with a very atypical parameters. The brightness of this object is 1,000 times greater than our best models predict, state scientists from the XMM Newton project working on the analysis of X-ray sources in the universe. This object exceeds the Eddington limit, the boundary at which radiation pressure should blow away matter, preventing further brightness increase. Since observations show that the neutron star can be 1,000 times brighter than this limit, it means our accretion models must be revised. NGC 5907 is full of surprises, and it's a paradox that the more we study it, the more it surprises us. raising more questions than answers. We still don't know exactly when and how the star stream formed. Was it a series of small accretions or one major collision? What kept the disk so thin and ordered despite past disturbances? How can we explain the behavior of a pulsar that exceeds our best simulation models for this type of object by a factor of 1,000? NGC 5907 has shown that even the seemingly calm cosmos pulses with a history of transformation, and that the beauty of galaxies conceals dramatic stories of destruction and survival.